Okay, everyone, welcome. We are half past the hour, so let's make a start. I appreciate this is the last session of the first day, so thank you very much for attending, and I hope you've got a little bit more energy left before the beers and the end of your day. So I'm Andy Fawcett, I'm VP Developer Relations at Heroku, a Salesforce company, and I'm here today to talk to you about 12-factor apps with Spring Boot. How many people in the audience have heard about 12-factor before we even get started? Oh, good number of you. Thank you. I know a number of you filled in the poll in this session as well, so thank you for that. So, I'm Andy Fawcett. I've been with Salesforce nearly 10 years now. Before that, I've been in the ecosystem as an architect, engineer. I've been in product management for a little bit, and now find myself building code and talking to customers and developers like yourselves in the role of developer relations. And Java and me have a strong affinity, as do I myself, as well as .NET. So I'm very excited to be, for the first time, here at Spring Boot. So, as you can see, we're inside Visual Studio. IDEs are a preference. I appreciate everyone has one. And I'm also running this deck from Visual Studio. It's a HTML deck. I built it with MARP. It's a little bit of a change of convention for me, so we'll see how it goes. And we're going to work through all of the different aspects of what 12-factor is, why it came about, and then contrast that as some of the features that are found in Spring Boot. We've also got a demo app, of course, to help us illustrate those points. So, what many of you are hopefully all thinking about and cognizant of is that building modern apps is challenging. It comes with its own things to consider, least of which writing the code, understanding the domain and the features that you need to deliver. Deploying it to the cloud has a complex set of requirements that don't just end when you've deployed it, they continue with patching and security and scalability, and lots of other things that mean that your app really lives or dies based on how well you're effectively managing your app in the cloud, least of which its features sometimes. Scaling is really important. The more popular app, the more scaling that needs to be required. Is that vertical? Is it horizontal? Where are some of those scaling requirements? And making sure that when you've actually finished it and it works well on your machine, it actually works well in deployment state. How many people have had that moment where it worked well on my machine? Well, I personally have had a number of those in my past as an engineer as well, and it's quite irritating because you're very proud of what you've built, but by the time it hits deployment into production, it's working in a different way. Maintaining the application in cloud environments is very important for those of you in the audience that are more involved with DevOps. Then they'll really appreciate us thinking about that as engineers, making sure that the configuration is managed in a way that's accessible to those DevOps engineers. So, with some of those challenges in mind, what has this got to do with the 12-factor application? Well, the origin of it actually comes from the Heroku founders more than a decade ago, when really a lot of this was still pretty difficult, as it is today. You know, a lot of challenges have been solved and things have been improved with frameworks like Spring Boot, and past platforms have come about in addition to Heroku that have solved and automated many of these things. But really, you can't escape thinking about some of the challenges so that you're aware of them, and choosing the right tools and the right approaches is really important. So it is a manifesto for robust cloud applications, and it's agnostic of language, it's agnostic of platform. It's simply a set of rules, 12 in fact, surprise, surprise, that really have you think about what it takes to manage and deploy an application in the cloud. So its core idea is a set of best practices that you can refer to, and we'll learn a little bit more about the open sourcing of this 12-factor definition in a moment. But it's designed for automation. It should be very easy to go from finishing your code, getting it through your source control system, getting it built and deployed and scaled into production. In the past, that's been very difficult for us because we've had to think about different steps of reviewing the code, figuring out scalability requirements, and connecting and configuring it all. But this manifesto states that that's not something we should accept. It should be very fluid, very frictionless to get your application into the cloud. It should be portable as well, really having options in where you deploy your applications to the cloud, whether it's even on-premise or even in the cloud, is something that should not be dealt with inside your application logic. It should be completely agnostic of where it lives and where it runs. And continuous deployment is key. It's a rapidly changing customer and demands around us all the times. Our businesses, trends, and customer demands are always changing. We need a strong iterative process that's robust and secure. Scalability goes without saying. So the 12-factor app really helps solidify all of these ideas and principles, and does that in 12 factors. So the 12-factor app is actually available right now. It's been available, as I say, for several years now on 12factor.net. This is what the website looks like. I'll provide the links and resources to this all at the end of the session as well. And we can see, really, I paraphrased it a lot in my description here of why it came about as a way of helping create a clean contract between the operating system and maximum portability between the environments your apps run on. And the background really is that it came from all of those that had spent a lot of time in the industry building and suffering these challenges and really felt the need to distill them. So here are the 12 factors, and we're not going to go through each of these painstakingly, you'll be pleased to know, at the last session of the first day, but we are going to highlight 7 of them which feature strongly in terms of what Spring Boot gives you. And this is great news, because you can then say, well, I'm actually compliant with a good chunk of the 12-factor manifesto by using properly those features in Spring Boot that we're about to take a look at. So we're going to take a look at the config. This probably won't come as a great surprise. It's a huge asset to Spring Boot in the way that it helps manage an externalized configuration. And the manifesto here goes into some detail. You'll see that these are only really a page and maybe a page or two. You know, the goal here is you can read through them very quickly and get an understanding. Right? These aren't kind of very, very deep, detailed things that you need to spend a lot of time understanding. We're going to talk about backing services. Largely, most apps that we build need some kind of persistent storage or even need to integrate with other services in a microservice architecture. So the 12-factor app has an opinion about that. Once again, these opinions are agnostic of languages or platforms. They're really here to get you thinking. And here's a really important one, which again, I think Spring Boot really does a great job at distilling. It's the fact that your code is your code and the configuration is completely separate, but together they form a release, a unit of a release that goes to the production environment. You can't have one without the other, but you must keep the two separate. So it talks about the code and the configuration forming what's actually known as a release. We'll also talk about processes. This is probably the most common one people enjoy talking about. What is a stateless process? Why does it have to be stateless? And our little demo app will show us, we'll actually be scaling our demo app and showing the effects of a properly configured application scaling effectively and being consistent in the way it behaves. If you don't get that right, some of those problems in production can be a little random to track down because it's hitting different servers that might have some memory or other kind of context. So statelessness is really important when it comes to scaling. We'll also talk about disposability, and this is actually referring to not just shutting down your service but starting up. And in the keynote today we heard a lot about how quickly we can actually configure our applications to spin up, which is really important because a lot of platforms and technologies, Kubernetes for example, will help scale our nodes up and down. Starting them super quick is really important for those end user experiences when you're hitting a spike. So thinking about what it takes to gracefully start up and shut down is really important. And we're also going to talk about dev prod parity, and this one we're going to talk about is really important to us because from my history as a Java developer, I've suffered a lot of this kind of class path problems and different Java versions, and that's the kind of thing I was talking about earlier. It's like, well, it worked on my machine, but when it hit the build server or the server running my app, I had different versions of Java or different class paths and things. So there's been a lot of innovation in this space, and we'll take a look at containers and the way that we can minimize that kind of difference. We're aiming for very much zero difference between how it behaves and runs on your individual development environment versus production. We'll also look at how you can actually emulate production as well. I'll demonstrate that. And finally, logs. Logs might seem kind of superfluous to talk about, but we'll talk a little bit more about how we can be more cognizant of what goes in our logs to make sure that other technologies can make better use of the information we're outputting or our frameworks are outputting. So those are the 12 factors, and let's take a look at the active maintainers of this. As I mentioned earlier, the 12 factor is a GitHub repository. The site you just looked at is backed by that GitHub repository. There are individuals from the Heroku business itself, AWS, IBM, Intuit, Salesforce, and independent developers as well, all contributing to it. And the question marks there really just to invite you, if this is an area after this session that you're interested in or have opinions, well, I think this factor should be defined that way, or we need a 13th factor. Well, you'll know where to go. We have a Discord place where you can discuss that with the maintainers and maybe become a maintainer yourself in the future. So it is a very active project. It's been around for a long time, but we've recently open sourced that to allow it to evolve into newer areas. But we do find a lot of the things are still very relevant. So the thing that excited me about this talk is realizing that Spring Boot has thought about a lot of these challenges, and there's a lot of ways you can configure it. And I think it's worth talking about how you can draw a line between the 12-factor manifesto proposals as well as those features, because its philosophy is about convention over configuration. It already has embedded servers, so we don't have to think about, oh, well, my code was running on Jetty on my local machine, but then in production it was running on Tomcat. It also helps us with production-ready features like our actuator, fantastic way of managing what state your application's in, but it's all implicitly handled for you inside Spring. And there's a natural alignment between Spring Boot's, the way that it supports the 12-factor template principles, which you'll see at the end of this session. So let's go and explore how. So next thing we're going to do is ground ourselves in a little demo app that I've built, and it's available right here inside this IDE, and it'll be part of the code as well as these slides I share afterwards. And then we'll explore each of those 7 core principles alongside Spring Boot. And finally, share some resources. So this is our 12-factor Notepad application. So this is time for our first demo. And I'm just going to walk you through very quickly what it does. You get a sense, and we'll highlight some of the things that you can imagine we'll be able to look at in terms of 12-factor. So I'm just going to go and run this. And the first clue of one of the 12 factors is knowing about your environment, development environment, production environment. You'll see that I'm setting my Spring Boot run profiles here to development, and that's very explicit in that I'm choosing to use a database H2 that's running locally. I'm also using an in-memory messaging queue environment because that's what I want from a development environment right now. But because I've used a different profile, that's necessarily not what I'm going to choose configuration-wise in production. As a show of hands, how many people use the profile capabilities really deeply within Spring Boot? How common is that, folks in the audience? Okay, about half. That's good. Okay. Hopefully this will inspire the rest of you to try it out if it's been a bit of a abstract notion for you in the past. So it's now running. Let's go and take a look at the application. We just go to localhost here, and we should see a little blank canvas. So the idea of this app is it's a sticky note app. Nothing too complicated. But what will happen if you notice, if I go and run a separate instance of this, and I go ahead and run that in its own desktop, and share both of those to emulate 2 users, you'll see that when I'm moving it around, my other user is seeing it, and vice versa. When I create new notes, they also pop up. I can even change the color, and you'll also notice that the text updates as well. So session Spring Boot, or Spring IO rather, and that will change on the left-hand side. So what we've got here is an app with a number of backing services. Obviously I'm going to store these notes in the database. The dev version, these notes will destroy because they're running in memory. And we also got another backing store that's doing all the messaging, some WebSockets behind this that's making sure all of the communications is synchronized between all the clients that are running this. So this is an ideal platform, and we'll show this later as to how to scale this out horizontally. Of course, you get more users using this app, then you need to scale out your API behind this. And the last thing I want to highlight is a slight aside, but one of the things that is really important, I believe, was with going into this AI era, especially integrating apps with agents, is making sure you have a strong API. So I've enabled in this app the Swagger protocol, and you can see it's already got Notes API for my CRUD operations, and it's very easy to do that, and I'd encourage you all to be thinking about that when you're building APIs. There's going to become a point where somebody will say, are you able to integrate that into an agent? And it's going to be your API that's going to make that a yes or no question. And furthermore, is your API documented? Is it understandable? So Swagger generates all of the schema for you that makes those AIs and those agents, and in fact anybody that integrates with your product, very super easy. So a bit of an aside there, but do give some consideration if you're building APIs to making sure they're super well documented. In fact, the descriptions that you give those APIs are also useful to AIs as well, just the actual human written descriptions. So that's take a look at the application that we've grounded ourselves in, and we can see it's got some key features. We can manage those notes. I can edit them on the fly thanks to it's an underlying message queue that is configured for development. They're organized visually. I can drag them around, I can delete them, and I've got that real-time collaboration that you saw me demonstrate. Now, some of these goals are obviously derived purposely to highlight some of the 12-factor. We need a simplicity and clarity to this, and really Spring Boot, one of the reasons that I absolutely love it is I like to keep my project really clean. And it's very easy just to see where my code is. Here's my configuration, here's my controller, here's my domain, and so on and so forth. So it's really simple and clear. I don't need to really know necessarily how it's actually running in production to know where all the right parts are in my application. Configuration and flexibility. Do I know that I can have different environments without my code? You'll see here in my resources, I actually have application.properties, but I also have application prod properties and application dev properties. So I can clearly see as a developer, oh, that's how it's configured in each of those environments. And of course, I could have different environments as well. And I want reliable data handling, so I want to make sure all those notes, precious notes, are stored. I don't know how many times I've had that moment in my career where my fond note-taking application has suddenly not spun up that day. I'm like, what am I going to do this day? I don't know. Where's my notes? So notes are super important to everybody. Response in real time, scalability in mind. So these are the tenets of the app. Those are design requirements. So let's start walking through the 12-factor app and how they apply. So the format of these slides, if you want to keep a track with what principle rather we're talking about, in the top bar there, you'll see a number 3 in the word config. That's the principle, the 3 of the 12 principles. And that bar will change depending on whether we're defining just the principle itself or whether we're actually talking about how it's applied in Spring Boot. So config, the principle here is to externally store your configuration, not in your code. Because our goal here is to take an executable, a WAR file or jar file, and make that just run it anywhere you like. The only way you can achieve that is if you don't hard code any assumptions about the configuration. So they might vary the URLs, the keys, and the host names. Config, that really determines how it runs, is not really considered environment config. If it's the same in every environment, it's largely just going to sit in your application property file. And it's not determining config. We're not talking about config that determines your bean structures here or that kind of configuration. That's kind of metadata in your app, really. So why we want to do this? Well, for one, security is important, particularly some of that config is secure variables or tokens or whatnot. And it's flexible. If we do this, we can then deploy it in multiple environments. And it's easy to update without reploying the code. Sometimes one of the bugs that we have in production is just we've made a wrong production config change. It's easier to change that than it is to change your application had you hard-coded those information. So in Spring, of course, just to start things off, there's a number of options. We can edit things in our application properties file. In this case, I'm hard-coding in my dev property file that I want to run on port 8080. Not a big deal for dev, but in the production one, I'd want to refer to my environment variable, and you'll see that pop up elsewhere in this slide deck. We also have the ability to auto-bind. How many people are aware that you've got Spring data source and Spring data source user and password? Those environment variables, just setting those alone and having the right things in your POM file will spring into magic and actually connect to that database. So environments that understand those environment variables can automatically trigger Spring to connect to those databases without you even having to change anything in your app or in your configuration. Now, sometimes you want to know what those environment variables are, so there's a $ syntax that's used in Spring. And sometimes, if you're like me, I like a lot of type safety. You can wrap those in a property, so it could be an integer, a date, or a string in this case, so you can get more type-safe access to your configuration, which is a really neat thing to do. Getting more advanced, Spring Cloud does have its own mechanism for centralizing it, because obviously one app is fine and dandy, but if you've got 2 or 3 or 4 or 5, a microservice set of applications, you might actually want to think about centralizing that configuration in something like Spring Cloud Config. Now, when it comes to configuration, it's also important to think about not just the connection details and things, but some of those are secret information that, if leaked, would be really bad for your business and your application. So never hard code those keys is the principle we're talking about here. Externalize all those secrets, prevent accidental exposure, and enable safe rotation and updates of those. There are platforms which will take those connection details to your Redis or Postgres or whatever external service and automatically change those credentials. And that's really important, that you have the ability to launch your app and relaunch your app every time those credentials change. Meet security and compliance requirements. So how does Spring go about doing that? We saw the dollar syntax earlier in the previous slide. Just as a reminder, you can do that with API keys. You can also use things like Spring Cloud Vault from HashiCorp. Also, AWS Secrets Manager is also a good option to consider as well. JASWAPT, Spring Boot, I think I presented that terribly wrong, does allow you to encrypt your properties values in your property files, but be aware that you still need to manage that secret that encrypted those things in a safe place. It's not the greatest of options, but just for completeness sake, I put it up there in terms of an option for managing secrets. I'd really start from the top down here. So attached resources, let's move to backing stores. Attached resource from the 12-factor percent is anything, literally anything, that you need to connect to from your app. So the most obvious ones are your databases, your Redis, your caching stores, or even other services. If you're running a microservice, you might have a microservice that's running your web client, and you might have a microservice that's running your API. Then those two are going to need to know what URLs they're both sitting on in order to communicate. So they're both backing store examples. All of these are backing store examples. So there shouldn't be really any distinction whether you're running locally or whether you're running remotely between how you express a backing store, which becomes really easy because, as you saw in the demo I just ran, I spun up that app because I set that the backing stores are just local, but the app doesn't know. It's still spun up JPA, it's still connected to a Redis store and things like that, simply because I just configured it to be different. So it's good to be able to change your profile, local or production, and not really have the attached resources make a difference to your code. And the flexible management allows admins to detach resources and attach other resources. Maybe admins or DevOps folks are doing performance testing and they want to attach a larger database. Well, they can do that if you've externalized that configuration. So I mentioned this just briefly before, but you can also do auto configuration with Spring Boot. If you happen to include the right entries in your POM file, your dependencies, in this case it's a Postgres one, then as soon as it detects having the Spring database and Spring Redis URL, then it'll automatically configure those. So if your environment or yourselves have explicitly set those, then those environments will automatically make those connections and your code will just work, basically. The other thing you can do is you can explicitly set spring.data source.url in your applications file, but again, don't hard code the URL. Pull the URL from an environment variable or some other externalized source. So either way, whether you use a straight and up an environment variable or whether you use your application properties file, you're still using an environment variable in this particular case to get that information. So it's detached from your app. Spring Data does an amazing job, and one of the other things that 12-factor talks about is that if you have a backing store, create abstractions over that backing store that makes it easy to use. You shouldn't, as a developer, have to spend time reasoning about how to connect to that backing store and how to access its APIs. So JPA does an amazing job, and in this demo that you just saw, I simply just created a repository and initialized that interface. I didn't need to do anything else because I only needed the CRUD operation. So it's a great feature from Spring Boot and JPA to allow us to just simply connect to that data store. And it even also uses my bean that describes the note to create the schema and upgrade the database. I didn't even have to write any SQL code to initialize the database. Spring Boot also did that when my app started. So connection pooling is another thing to think about as performance grows with horizontal scaling. Hikari CP does that out of the box. By default, there's no manual config required, and you can also tune it if you like in your application properties. And this would rather probably go in your application prod properties, so I need to update my slide there. You wouldn't probably put that in your base property file, you'd probably put that in your production property file. So you're probably thinking now, well, what else do we do with the demo app? It's just running happily in local there. Well, we're actually now going to go ahead and deploy it to the cloud. So I'm going to do that because I want to be able to show you how the fact that these services are stateless matters, and how you can detect that they're stateless. So I'm going to go ahead and deploy those to Heroku. This could be any container-based PaaS platform your heart's desires, but we're going to do that because that's the one I'm obviously most familiar with. Heroku just needs to know the name of my app. It'll actually make up a fun one if I don't give it one. In this case, we've got Sleepy Spire today. And I'm going to provision some backing stores. I actually need a Postgres database and Redis. So I'm going to let it churn away on that while we move on to the next part of the presentation, and we can come back to that. You'll see that it's already created the app, and the provisioning of the add-ons is already started. We can see Postgres going there, and if I refresh this, we've also got Redis. So let's just close that back for a moment and move this down. What does strict separation of concerns mean when it comes to building, releasing, and running? Well, it kind of hints at what I was talking about earlier, is that when you build your application, create an artifact, and this applies to any platform or any app, whether it's a Java or not, that is completely agnostic of how and where it runs. So no environment-specific environments. When it comes to release staging, what happens is you actually combine that configuration, your set of environment variables, you literally record those environment variables and your artifact, your WAR file, and those two artifacts together become a release ID. Now you might think, well, I'll remember my environment variables, but if you're in a hurry and you do another release and you overwrite them, you've actually changed your app. Your app is a part of your configuration as much as it is your code. So it's really important that when it comes to rolling your app back, if anything happens, you know what configuration you've set as well as what your code is. So that's why it's a good separation of concerns to have configuration out of your code, but also it's good to remember the configuration that you did. So fortunately, Spring does a great job of this in terms of building either with Gradle or Maven. You can actually package your application up, and as we'll see in a little bit later, you can actually create a Docker image and deploy that to a container service and scale it very easily. CI/CD benefits from this as well, because of course those environments, whether it's testing or performance testing or auto testing, will want to take your artifacts, your code, but also apply their own configuration to test it accordingly. So the sample app that I've created automatically uses Maven. It injects the Spring data source and Spring Redis environment variables into its config. So what we're going to do is look at how we can execute things in a stateless process now, and why this is important. So I hinted at this at the beginning of the session. Running as one or more stateless is really the rule here. Making sure you share nothing between those services, because that constitutes some state that will trip you up in the future when you're scaling. Persistent data lives in your backing services, so we just kicked off some provisioning for those. And why? Well, it's horizontal scaling. Those services have got to be consistent. If there's 2 or 10 or 20 or 30 of them, they've all got to be consistent. And the only way to do that is to have backing stores. It makes it resilient as well. At some point, maybe some of those nodes go down, or somebody descales it. Well, you can get resiliency back by remedying that by scaling things back up again without having to change your app. So we're going to explore what that looks like in a moment now, when we look at how REST APIs are dealt with in Spring Boot, because they are also stateless by convention. And if needed, we can also use session state, and that's really important because by default that's stored in memory, or it might even get persisted to a local disk. That's bad news for horizontal scaling. So our sample app uses Redis for the real-time collaboration that we saw, but it also uses Redis for the session state. So avoid storing critical data, even if it's tempting, like, I guess temporary files in the moment might be okay, but you have to think about the timing of those. It really is a bad a problem if you're storing these and persisting these things on local disk. So let's have a look at the second part of this demo now, and we'll see how we can observe whether our app is actually handling horizontal scaling or not. So our application has been provisioned. So I'm just going to get this into the cloud pretty easily with the Heroku git push Heroku main, and this is actually building effectively a container image of this application and hosting it inside Heroku. And you'll see after a while some of the familiar build artifacts from a Spring Boot application where it's downloading all of the dependencies. Here it goes. But this isn't running on my local machine. This is running on a build server hosted in Heroku that's doing all of the builds. So I'm already getting consistency now. Once it's finished building that image, it's actually called a slug or container, it'll actually then start and run that up. So one of the things I'm going to need to tell it to do after that, though, is I'm going to tell it to scale, because I've only got one web process, because I need two to demonstrate to you all how we've got this pattern nailed down in terms of 12 factor. So now that's up and running, and let's just tell that to scale, and we can see our application in action. And I've actually implemented some tests. Although session state isn't really important to this app, I actually just created a spoof session URL so you can see a session counter come back, and we can kind of experience what session state looks like. So that's all up and running. That's literally deployed to the cloud. It was running locally 10 minutes ago. It's now running in the cloud. And let's use Heroku Info just to grab the URL, because I'm going to need that. It's random by default. So there's Sleepy Spire. Let's take Sleepy Spire and see what we can do with that. So let's go and use our API session.test. Now zoom that a little bit. So the key thing to watch here is I'm going to sit and refresh the page. The session ID and the counter does not change. But if you notice the host does, I'm running 2 nodes. And the host is changing. It's relatively random. There's an algorithm behind it, but that's the load balancing action, right? So it's scaling horizontally, but our app is behaving as we expect. The session count is always a session count, no matter who I ask. And the session ID is always the session ID, no matter who I ask. So we take this a step further just to illustrate how important it is, not on localhost, how important it is to the app. Because obviously if I'm moving things around, I don't want the stickies to appear on the left, on the right, depending on which server got the particular request. That would be really bad for this application and its experience. So I'm just going to do the trick of running it up in 2 split windows for you, and we'll have a go at this. So this is now running in production, and we've got our sticky notes app, and we should have a sticky note down here. I have to fix the code a little bit as to why it always puts it at the bottom. So already we can see things are behaving as we expect. We're getting the sticky note. I can change the color. All of that seems to be working. One thing I've done just to really illustrate what I've just shown you is that this is now horizontally scaled application. I go to the developer tools in one of my browsers. We can ditch this one. And let's try and zoom that up a little bit. If I move this around, we can see the host ID changing. In fact, there it is. There's one host ID and there's another host ID. So it's correctly confirmed that my app is behaving in a perfect way when I horizontally scale, because all that service is completely stateless. The tiniest bit of state that creeps into that code, a static or whatever, it's going to break. So I'm very happy. You can obviously build a lot of tests around that to prove this as well from an automation point of view. So let's get back into the deck here. Do give me feedback as how this sort of deck inside the ID thing works. I'm curious. But anyway, disposability, fast startup. This is an easy one. We talked about this earlier. The principle here from 12 Factor is processes are disposable. You should be able to start and stop them quickly with no resilience on local state. So if any time you're doing something and you think, what would happen if it just instantly died, and you think that's going to be bad, you need to do something about that. Your app should be able to just stop in its tracks because somebody's scaled it down or there's been a catastrophic failure, and it manages that. So starting and stopping really quickly. Why is that important? Elastic scaling, as we just saw. Rapid deployments makes it robust. If failed instances are failing for whatever reason, they can be replaced instantly. Maybe you've got some leak somewhere in your app, and it reaches a point where it just dies, then it'll die and then spring up another one, and it'll continue. Eventually you're going to have to solve for the leak, right? But these sort of things can help keep your app alive if you've got some leaks. Disposability is how Spring Boot manages this in terms of, if you look at native, in terms of startup speed, we can see Spring Native is a technology based on Grail VM that helps us even do faster boosts. It was amazing in the keynote this morning to see how some of the JIT compilation timing and things is being evolved and changed. That was kind of mind-blowing, how we can even get that to work even faster. Actuator is a great technology for many platforms to look into your app, to ask the app how it's feeling, rather than intuiting, oh, because it's not responding and maybe it's down. Actuator does an awful lot of the work for you to really help platforms be more informed about your app's state. And you can also do probes for health as well. So it's a lot of metadata with Actuator you can get about the health of your application. And again, it's just a POM file dependency away largely for you to add that capability. So keep environments simpler. This is the last demo we're going to do, and this is what I was talking about earlier. How many times have we all been in it worked on my machine and it didn't work in production? So the principle here is remove the gaps between getting your code into test and into production. Make sure that you think about the tools that are involved and some of the policies that you've got in place. Why is that important? Well, avoiding that surprise. It yields more reliable releases the more you tune and squeeze that process of getting it from your fingertips out into production. And it also helps CI/CD and continuous integration. So Spring helps us with DevProd Parity in some respects to help us configure our profiles. So we talked about the port setting being hard-coded. That was fine for dev. But if you're using a port and an environment gives you that because it's managing the HTTP networking for you, then you must honor the port that it gives you. And that's why you can use the $port syntax here and automatically inherit that. You can also embed, Spring Boot also has embedded servers, so even though I was running locally, it's running the same embedded server it was running for me in production. I didn't have to think about that, I just know that that's what Spring Boot does. So let's finish up with our last demo, and we're going to build a container image here, because there are times maybe you actually just can't figure it out. If something's failing in production, and you just need to debug it or run it locally. So what we're going to do here is grab our packed command. I know Spring Boot does have a means to run and build images. Full disclosure, I couldn't get that working on my machine. I think that's something to do with my company's security policies, but I'm just going to run packed, which will do the build. And you'll notice that it's very similar to what I just did with git push Heroku main, and that's intentional. These build packs that we use, how many people are aware of cloud native build packs as a technology for, anybody else building with Docker files should immediately go and look at CNB. It's a way slicker way of building container images without getting into kind of managing oodles of Docker file syntax. So the point here is that when I did git push Heroku main, it built a container using a build pack. When I'm running it locally, it uses the same build pack. So I'm getting closer to my development and production environment. So the one thing I'm going to do here, though, is I want to get hold of those backing services that I provisioned. And in this scenario, I know nobody else is using them. I'm not proposing you go attach to production services, but do so at your own risk. But I'm just going to get my .env file from Heroku. I won't show you the file for obvious reasons, but it's got all the Spring Boot environment variables in it that'll attach to that Redis and Postgres database. So that's populated my .env file. So now I can go and run that Docker image, and that just runs up Spring as you'd expect. And we should be able to go to localhost. I've stopped the original localhost running that we started this demo with, and yep, that's running. So we'll get rid of that one and that one and that one. Let's just go to a new localhost. And the interesting thing about this, although I ultimately didn't do a lot in production, is that already had a sticky note because I'm live on the database, but I'm running locally. That's my local database. So we can actually do something more interesting and go and find that original Heroku deployed URL, which will be back here. There it is. Right, opening a new terminal. do Heroku info, just to prove we're attached to the same backing services. But I'm running as close as I can a production runtime environment. That container used the same build pack when I deployed it as the build pack that I've just used now. And again, I'm using exactly the same environment variables. So I can prove that by just opening up the app in another window, and the two will talk happily together. So that's the deployed version of it. And that's the non-deployed version of it. So if we just make those work into separate windows, and it looks like the zoom level's slightly different here. Maybe I'll just drop it back to match. There we go. So we should now find that they moved up. There we go. So that one's running on localhost, and the other one's, so that's a bug in my JavaScript code, by the way. For some reason, if I'm a bit too late. There we go. So it's running now against the two backing stores. One's local, running in Docker with pretty much exactly the same configuration that it's running in production. So if I had a problem, I'd now stand a better chance of figuring out what's going on. But bear in mind, it's only really going to be the difference between your config that's going to drive those problems and the behavior of the app. So let's start to wrap things up here very quickly and move on to logging. Logging is a principle that not everything out of standard output is good for machines. It might be good for us, but please make sure that you concern yourself with the machine-generated output. So make sure at least it goes to stud out, which happens to be the case in Spring Boot, but never write those log files to any persistent store that the ops person or others are not involved in, because you might be leaking things from your logs that are sensitive from a user's point of view. And make sure that the log management is external. In our case, we don't care about managing our logs, but make sure that you can plug Papertrail or Log4j or other log systems into your application with ease, and that's obviously another environment variable. So with Spring Boot, you can configure those logs. They go to stud out. There's no log file storage with Spring Boot, but you can use logback Spring XML to configure that structured log output. OTel is more of a more of a greater innovation these days. You can actually say to OTel, and there's many OTel providers that actually consume your log data, what type of log entry is it? Is it telemetry? Is it just informational log? And it does lots more interesting things with your log data. So these are very good techniques to use with stud out, but actually I would encourage you to investigate OTel as a new format, and there are a lot more tools that are available. It's an industry standard for consuming log outputs. Had I had more time, I might have done an OTel demo with Spring Boot. So the key takeaways here are that it simplifies the way that you have to think about these. Don't not think about them. Every developer in this room should be responsible for their code in production. It doesn't just stop when you check it into source control and go home. You've got to be responsible for that. And the ops people are responsible for production as well, but these 12 factors help you be aware of the things you have to think about as a developer. And hopefully with this session, you now know some of the things in Spring Boot that help you actually implement those. It's your ally, Spring Boot. So start small with the factors. There's 12 of them. They're a page or two each. It might seem a bit overwhelming, but look at the ones that are most important to you. If you're constantly having problems with the parity between development and production, or you're having problems updating configuration, it takes time to update configuration, look at some of those and how you can solve those problems. Maybe some of the other factors are not that important to you. So choose which ones, 2 or 3 ones to make a start on. And Spring Boot and Spring Cloud, obviously, as we saw in this session, are massive steps up. But you do have to think about how you're using it. It's not automatic. In some cases it kind of is, which is cool, but in other cases you really do need to think about how you configure Spring Boot, Spring Cloud to really obey the 12 factors that we've been talking about. So if you'd like to know more about the 12 factor, here is your opportunity to get into Discord. You can take this QR code, scan it. I'll also share it in the session messages later. So I'll give you a moment or two to grab that. If you really sat there thinking, I'm dying to talk about that particular factor, that build one, then maybe you'd like to join the people that maintain it and have a conversation about it. And finally, here's the code. So I chose to put all of the code and all the slides in one repo. The slides also have more notes as well. I try often to read notes from slides, I've just never been able to do it. So you'll find there's probably things I've missed in this talk that are in the notes. And if you open the HTML file, presentation.html, it comes in a nice viewer like you just saw. Click the speaker notes, and it will show you more notes. So with that, I think we're entering into Q&A realm. Otherwise, thank you very much for watching, and please find out how to connect to me. I'll be around in the happy hour. Thank you very much.